I've been working in Vetigrow as a team lead in R&D department. So we deal with spice cultivation in soilless systems. So why soilless, I will explain later. But for now, it is just to protect from abiotic and biotic factors. So this meeting's agenda is to give you a in-depth knowledge about soilless crop cultivation, not only spice, basic info of soilless crop cultivation. Then we will go into spice cultivation. Then its advantages and disadvantages and market opportunities. These are the four things we will discuss in detail in this webinar. So for basics, we have to know what is controlled environment agriculture. So like there are many factors which tends to give poor growth or inconsistent growth in traditional way. So for example, unexpected rainfall or severe heat storm or hailstorm, something like that. So controlled environment agriculture is basically we are controlling uh, these factors like pests and other factors also. So we are controlling some of the many factors so we can give a consistent yield. This is the basic intro of controlled environment agriculture. So the advantages of it is as we are controlling the biotic and abiotic factors, the consistency of the yield is increased. So for example, a normal farmer in a traditional way may not get the same yield in every year. So here we can assure that we can get the same yield. So and as the climate change is getting I mean severe in these days, the traditional farming cannot withstand it. So the only way we can give a consistent yield would be a controlled environment agriculture. And another advantage is increase in yield and quality. This is due to that we are giving the ideal uh, conditions for the crop, so it can give its maximum genetic potential. So the disadvantage of this would be for now the capital investment is way too high, so not everyone can afford it. Exactly, the farmers can't afford it right now, and the production cost, the capex is also too high. So these are the main disadvantages right now. But as that climate change gets severe and severe, these issues will resolve automatically due to the only production method which is sustainable. We can go forward with this. So exactly the same reasons why we are not going into traditional way of cultivation is that we can't control the factors as I explained, and inconsistent production capabilities and lower yield. I will explain this with turmeric as an example. So we met a farmer in Kerala who's getting around 16 tons per acre actually. So he said this 16 ton is not consistent yield. The first year he got 16 and the next year he got 10. So it varies depending upon the climatic condition on that crop cycle. So in case if the rain damages a particular field, the yield will be low. So we can't control this factor. That is the only reason we are not going with the traditional way. Why soilless? Actually, soilless. If you have heard of hydroponics and soilless, they're both similar, but the only difference would be we can consider a hydroponics farm as a soilless farm, but you can't consider all soilless farm as an hydroponics farm because we don't use that NFT type of thing. We use trough or grow bag. So uh, that's the reason we can consider it as a hydroponics farm. And advantages would be no production loss. There is no disease or pest or anything that will affect the production and giving a consistent production and higher quality as we are giving the plants with the exact nutrient requirement of the crops. We are getting a highest quality and higher yield. So export quality, as I mentioned, these quality parameters are like for exports, there are some quality parameters which can't be achieved in a traditional way, which can be also achieved in a traditional way, but it is not consistent. So if in your particular field, soil is been infected with fusarium These are some bacteria which can cause root rots. So if in that particular crop cycle this happens, in while inspecting for the quality, your produce may get retained. So that's the reason. So for example, we are taking turmeric as the crop for the day. So basic info of the crop is it is usually 9 to 10 month crop cycle, but it varies upon the variety. So there are some varieties which have 6 month crop cycle, which has been developed by the Spice Research Institute in Kozhikode. So ideally it is 9 to 10 months. Extracted from turmeric is curcumin. There are many other compounds also, but the main is curcumin. Uh, just a minute. Yeah, there is some network issue. So exactly. The ideal conditions for turmeric cultivation is the temperature should be around 25 to 30 degree, and the humidity should be around 80. It can increase, but not in a permanent way. Like and the light conditions should be partially shaded. So if the crop is exposed under direct sunlight for long hours, it can get scorching and all. So it is best to keep turmeric cultivated in a partial shade. So usually we use shade nets around 50% diffusion, so that it won't get scorching effects. And the nutrient requirement is split into two stages. So first 150 days should be vegetative growth, where it will grow that I mean the plant will grow first and the rhizome will grow next. So for the first 150 days, the nutrient will be focusing on higher nitrogen rich fertilizers. So then the rhizome development stage will have higher potassium levels than nitrogen. So to facilitate more rhizome growth. Then ECN pH is around 5.5 to 6.5 is the ideal pH for the every crop and also for turmeric. And ppm will be around 2000 ppm. I will explain what is ECN pH in the upcoming slides. Uh, and the conventional yield of turmeric in soil is around 16 ton per acre, and in soilless we get around 24 tons per hectare. Acre, sorry. And the dry recovery is around 20%, and all this data will vary according to the variety. So some variety can give 32 kg, 32 tons, some can give less than that. So it may vary. We can discuss. So these are the varieties. So in this slide we are seeing the varieties developed only by Spice Research Institute in Kozhikode, and you can select the varieties according to your needs. Like if you're in a according to the climatic conditions of your zone. If you're in a zone with higher humidity and higher temperature, there are particular variety which will do well in that zones. There are some varieties which may not do some that good in that zone. So it is purely according to that your climatic conditions. If it is good, you can go with any. And this ISR Pragati and Pratibha are around 6 month crops. So you can cultivate around two crop cycle in a year. But the only disadvantage would be the climatic conditions. If your area is not suitable, then you can't opt this. And these are the normal varieties other than that developed varieties. So other than this, there are few more local varieties which are I have not mentioned here. So and they go with many names, so we can't mention which one is which. Particularly, we are doing CO2, which is developed in Coimbatore Institute, Tamil Nadu. So, which has a curcumin of about 4.2, which is ideal, but it has a very good resistance level for disease and pest. So, which is very important. Even though we are growing in a controlled environment agriculture, pests may enter. This is we can't control this is that much, because if the humidity is way too high, uh, disease tends to come. So going with a resistive variety is a good option. So then generally in soilless cultivation, not only turmeric, there are few steps you need to know. Like not only soilless, in hydroponics also. So what is pH means? I- the level of pH in the irrigation water determines the availability of nutrient to crops. If the pH is way beyond 5.5 to 6.5 range, then the availability of nutrients will reduce. So, and the solubility of nutrient will also decrease. In, for that reason only, new type of fertilizers are being delivered nowadays, which are uh, EDTA. It will be mentioned EDTA, which are actually coated fertilizer. A single layer of coat will be in the fertilizers, which will prevent the fertilizer from being reacting to other fertilizer mixed in the water. And also in higher or lower pH than that, this fertilizer will be stay dissolved. And the disadvantage of this EDTA fertilizers would be the cost. The ideal cost of fertilizers will be around 20 rupees per kg, but this tends to be around 200 or something like that. So generally farms use micronutrients as EDTA. So we don't use much micronutrient in our farm. So going with EDTA for micronutrient alone will be feasible for us. So the next thing you have to look for is EC. EC is electrical conductivity. This determines the combined nutrient level in the water. So if you are adding more and more nutrient, the electrical conductivity in water will increase. It can be measured in three ways. Total dissolved salts, which has a unit called parts per million, ppm. They will measure in ppm meters, and EC is usually measured in microsiemens or millisiemens. These two is interchangeable. You can derive one from another, so that's not issue. If you're going from the beginning with EC, try to I mean ppm. It will get confused because different the TC meter suppliers will have different readings for EC to ppm ratio. So it is better to have one supplier and sticking with them. So next thing you have to do in farm are scouting for pest and disease. Even though it's a controlled environment agriculture, pest and disease tend to come, but it is in a very minor way. So it will not be in a much of a scale, but it tends to come. So looking forward for it at the initial stages itself will solve the most of the issues. So usually pests, if you think of pests, there is only 4 to 5 in greenhouses. That's you can see aphids, and then caterpillars will be there, grasshoppers, and spider mites, something like that will come. But these are easily treatable, and there will be no pest residue in that crop that you are producing. Disease are due to that low oxygen content in your irrigation water. If the dissolved oxygen content is low in your irrigation water, it will attract anaerobic bacteria, which will cause protection losses. So it is always advised to check DO in your water before delivering it to your folioses. So then what you have to check is media moisture. Media moisture is checked with an instrument which have two probes, two metal rods, which we have to stick into the media. Like for example, in soilless, it will be coco pit. When we stick in the coco pit, it will show from the scale of 1 to 10. It is ideal to keep it around 5 to 7. If it is above that 5 to 7 range, disease or it becomes prone to disease. If it is below that, you need to irrigate your farm. Then flushing and leaching of media. These both are done to prevent salt accumulations in the media. So flushing is a method where you will use RO water or distilled water to completely flush your media. So you will drench the media completely with this water, so that that sedimented salt deposits will leach out with that drainage soil in the bag or trough. So this is done to prevent accumulation and stress to the plant. And you can, for leaching, you can do tests, like if you're giving 1000 ppm of nutrient, and while the I mean drained water is having around 600 ppm, you can consider 400 ppm plant as utilized. And also same for the pH. The only thing in pH, that if you're giving a uh, irrigation water has a 6 pH, and after the draining you're having a pH of around 8 or 9, that is the correct. Once the plant started taking nutrients, the pH should increase, not decrease, or stay the same. So when the pH starts increasing, it is an indication that plant is taking nutrient properly. And as I mentioned, dissolved oxygen should be higher to avoid disease. And the next thing we will look for is light intensity. So there are many units for this. So we generally photosynthetic active radiation, that is called PAR, is mentioned around 400 to 700 nanometers. So it tends to vary for different crops, but this is the ideal range. Then the which I mentioned here is photosynthetic photon flux density. This is the active photon rays that are landing on the plant leaf per square, like per square meter. So this is, we have meters for this calculating this photon flux density, and they may cost you around I guess 10,000, and they will give you a specific reading like 10,000. I mean, for in lumens, it will give 10,000, 20,000 lumens. In ppfd, it will give around 150, 250, 300, 400, something like that. Uh, for leafy greens or and smaller crops, it is okay if the ppfd is around 150 or so. For turmeric and other wine crops like cucumber and so energy intensive crops, it is better to have 300 or 350 ppfds in the particular site of your farm. So these are the tools we will use in our farm. So first is that I mentioned this, that soil moisture meter. It will have a scale between 1 to 10, and it is multimeters. So you can check pH of the media from the same meter. You can check the light intensity, but both that pH and light intensity will not be accurate as if you are checking in an individual meter. So it is better to use that for only soil moisture. And the second one is EC meter. So uh, actually second one is for dissolved oxygen. So it gives you a reading of how much dissolved oxygen is in your irrigation tank or irrigation water. So the higher the dissolved oxygen, it is greater. I mean, it is good for the plants, because anaerobic bacteria are the bad bacteria which tends to start diseases in crops. So higher the oxygen level, the anaerobic bacteria cannot multiply in those conditions. So good bacteria tends to grow, which is both beneficial for plants also. So they live in symbiotic conditions, so that plant will also get benefited from the bacteria. Bacteria will get benefited from the plants. So DOs and essential parameters which should be checked every day. It can be increased if your DO is very low. You can increase it with hydrogen peroxide. So concentrated hydrogen peroxide, you should have stock in your farm. So if the DO is low, you should add more hydrogen peroxide, which will increase the DO rapidly. As hydrogen peroxide has two oxygen molecules, uh, the level of oxygen tends to increase in that hydrogen peroxide if added. Then the next thing is temperature and humidity meter. So this meter which I have shown the slide is having two temperature readings, one for the outer side, outside the greenhouse, one for inside. So we can check how is the relative temperature and humidity. So these are somewhat accurate, but it is better to have something than nothing. So every farm will have something like this, and the reading should be temperature should be around 25 to 30. It is ideal for turmeric. If it is going above that, the turmeric leaves tends to swell around, and the photosynthetic rate will decrease. So it is better to maintain this temperature. If you are going with the controlled environment agriculture, so you will have machines to control these temperatures. There are automated system and as well as manual system. If you are seeing a temperatures way above the limit, you can use humidifiers and fan and pad systems, which will decrease that temperature, but it will also increase the humidity. So for humidity, you should have a dehumidifier. Dehumidifier will decrease the moisture level in the air so that it will prevent disease formation in leaf. So the next thing is that the ppf limiter. So you may need this one time only for a crop cycle. If you're while selecting your site for the farm, at that particular period only you will need this ppf limiter. Once you have selected a farm which has ideal light conditions for the cultivation of crops, then you may not need this one. It is like one time thing. The next one is EC and pH meters. So this came in, I mean, this can be regulated with solutions like pH can be buffered with, if the pH is low, we will add more, I mean, alkaline liquids like sodium hydroxide works better. You can also buy something like pH up and down. There will be mentioned pH up and pH down in e-commerce sites, so you can get it as well. But if you're not having it, you can use just acid and base. Like for acid, you can use the hydrochloric acid, but it is not recommended to use hydrochloric acid. Nitric acid or phosphoric acid it is recommended. As per your wish, you can proceed. And the next thing is temperature sensor. This temperature sensor is a camera which we can see the actual leaf temperature in the plant. So there is two temperatures. One is ambient temperature and another is leaf temperature. If the ambient temperature is above the limit of 30 degrees, but the plant temperature can still be at 30 and the leaf temperature. This is due to it will start transpirate. I mean, the process called transpiration where it loses water to stay cool. So if you are having the temperature camera, you can see the leaf temperature. If the leaf temperature is way beyond 30 degrees Celsius, then it is very difficult for the plant to cope with it. For 1 or 2 days, it is not going to affect the crop, but if it is exposed to for at this temperature for long duration, it may experience stress and die soon. So it is recommended to keep the leaf temperature at the ideal conditions. And these are the important charts. As I mentioned, pH, we use 5.5 to 6.5 pH because at this pH only all the elements, nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, and micronutrients, this tends to be more soluble in water. If you are going to 4 pH, if you see the thickness of these lines, it will be very thin at 4 pH. That is because at 4 pH, these nutrients cannot be in a soluble form and cannot be uptaken by plants. So it is equally important to check the pH every day and maintain it around 5 to 6.5. And the next chart is nutrient antagonism chart. This shows you if one level of nutrient is higher, will it affect the another nutrient, like another element? If your potassium level is higher, it will directly affect your iron level. I mean, affect your magnesium levels. It will affect your boron levels. So everything should be in ideal range. If one nutrient, one element is higher, then it will drag down all other which is linked with this to an unavailable form for the crops, which we don't want. So it is ideal to balance our ppm element wise, which we'll discuss later, before giving to the crops. So the next thing, most of us will have seen the deficiency chart. It mentions how it will look. So yellowing of leaf will be caused by nitrogen deficiency, or whitening of leaf will be caused by iron deficiency. So this is not accurate, because different crops will have different indication symptoms. But for an overview, you can use this chart. So as I mentioned, the nutrient levels. So the nitrogen should be kept in the 170 to 180 ppm levels. Phosphorus should be in 110 to 120 ppm, and potassium should be in 200 to 240. These three element is called macronutrient. Uh, Calcium and magnesium is called secondary nutrients. So we will not include that in this, but it is kept under 200 to 230, 220 to 230 range. Magnesium is 40 to 55 range, and this micronutrient is given in combo, like Rexulin. So Rexulin is a brand. I mean, Yara produces Rexulin. It is a combo of these nutrients. It is better to keep this in this range, but it will change as per the crop. If you are having a crop which doesn't need this much nutrient, for example, like leafy greens or some short duration crops, you have to adjust this completely, because this is specifically for spice, like turmeric, ginger, ashwagandha, something like that. But for other crops, you have to decrease it. So after finalizing your ppm element wise, you have to use an software called hydrobuddy. This hydrobuddy software is open software, so everyone can use. You can search in chrome. So it will ask inputs for these elements. So it will ask nitrogen how much input you want. So after filling this data in that, you should select which sort of fertilizers is available with you. So typically in soilless and hydroponics, we use water soluble fertilizer, which are very different from this normal traditional NPK, urea, and all. So this tends to be costlier, but it is completely water soluble. It will not deposit under the tank. It will not. Uh, Generally, it will not react with one another, except few, like calcium and magnesium tends to react with each other. Other than that, they tend to be dissolved for a long time. So in the Herobody software, you have to select what are the water soluble fertilizers you have in your farm. So after selecting those, it will give your weight readings. So for example, if you take potassium nitrate for potassium and nitrogen, it will say in this ppm, you have to add, you have to add this much. Uh, just a minute. So exactly, and that after inputting your data, like I want nitrogen this much, ppm, phosphorus this much, potassium this much, then it will give you an output. And that output will be like add 200 grams of potassium nitrate in 100 liters of water. So it is the best software we have, which can give you an exact reading of how much you want. Uh, you can try that also. Then turmeric. As per turmeric, there were two sowing methods. So after you selected the variety which you want to grow, there are two ways you can grow them. Either you can start the seedling by direct sowing method. which is generally shown in the image. This whole rhizome is kept in the media, inside the media. This method is great as per the plant growth, but it tends to be the seed rate will be higher, which will cost you more. Uh, but the growth vigor will be higher because the plant will not need nutrient for few many days after growing because the rhizome itself will have the enough nutrients. But the next method is single bed method. This we tend to divide the rhizomes into 3-4 pieces. Each piece will be around 5 to 10 grams. Each piece will be have at least 1 or 2 buds. So we tend to keep these rhizomes in pro trays. These trays will be filled with cocoa or vermicompost, something like this. Then it will be nursery for around 30 days. In 30 days is for both germination and plant should have grown around 3 to 4 inches. So at this stage, then it is been transplanted. So the disadvantage of single bed is after germination itself, you have to start giving nutrients because as we have divided the rhizome into smaller pieces, the rhizome will not have that much nutrient to provide to the crop, the plant. So if we have to start giving nutrient from the beginning itself. The advantage is seed rate is way too low. So instead of spending 1200, I mean buying 1200 kgs of turmeric as a seed for an acre, you can get around 300 kgs, which is sufficient for an acre in this method. So this is the cost of cultivation for traditional soil farming. Uh, the major cost goes with seeds, manure, land preparation, and all. So the total cost of cultivation is around 1.2 lakhs, something like that, 1 and 1.2 lakhs between that. So you can look for that, and it may vary according to the landscape you're in. So geographical conditions, like in Tamil Nadu, it is in this range. Tamil Nadu and Andhra, it will be in these ranges. So it may vary from state to state. So this is for soilless cultivation. This tends to be consistent in all geographical conditions. So, like if you it is mentioned here, it will cost you around 1.85 lakhs. This is only capex, not I mean only operational expense, not capital expense. This capital expense will be exactly similar or maybe have little changes according to the state you're in. But uh, that's it. The major cost in this cultivation is nutrient because that's the only thing which is water soluble, so it will be much costlier. So and we are also giving what the crop need exactly. So this drives the nutrient cost up. So that's it. Then market trends. Nowadays, turmeric prices are at all-time highs. So it is around 210 rupees per kg. This I have mentioned. I forgot to mention one thing that 24 tons, which I mentioned as a yield, is the fresh yield. There are two yield parameters in these crops. Turmeric generally is the fresh yield is the yield you get after harvesting it. And we have dry yield. Dry yield is after the post-harvest process. You have to boil the turmeric. You have to polish it. You have to dry it, and after this process the yield tends to reduce by 80%. So you will get ideally the dry recovery ratio, percentage is around 20%. It may increase as per variety, but usually it is 20%. So if you are uh, getting 24 ton fresh weight, you will get 20% of it, or likewise. So these prices mentioned here is all dry weight, for dry weight. So for 1 kg of dry turmeric, it is around 210 rupees. The highest, in costliest market, and average price is 160. And these prices are increasing at the all-time highs due to the increasing demand in domestic and international market.
इसी यमुनानगर को ज्ञापन सौंपा है और
Uh,
बातचीत करते हुए कहा
Hello,
कि प्रधान विजय कम्बोज ने बताया कि ग्रामीण रूरल ऑडिटर की मांगों को लेकर आज हरियाणा सरकार के खिलाफ
hello.
जोरदार किया जा रहा है। इस संबंध में हमने पंचायत सेक्टर के नाम डीसीएम नगर को ज्ञापन सौंपा है। उन्होंने कहा कि आज ग्रामीण 12
Uh,
वर्षों की हालत बहुत ज्यादा खराब है।
That's it for today's event. And the conclusion is that controlled environment agriculture is currently not viable due to its capex and opex, but due to the increasing climate changes and adverse reaction of it, the traditional way of cultivation may not withstand for a long time because due to severe heat storm, floods, uh, high rainfall, like these parameters we can't control, but in controlled environment agriculture we can do that. So in future it will be in spotlights, so that we are looking forward for soilless cultivation from the beginning right now. So it is good to know the knowledge of basic idea of soilless cultivation, so that in future you can easily switch between it. So if you have any questions you can ask.
So the first question is, how does spice cultivation in soilless systems compare to traditional soil cultivation?
In the sense of agronomic practice or in economic way?
Economic way?
Economic way is the difference is around 80,000. So in soil cultivation, it will cost you around 1 lakh per an acre, and in soilless cultivation, it will cost you around 1.8 lakh. This is only the operational expense, not the capital. The capital initial expense will be higher in soilless and controlled environment agriculture. But you don't have that capital expense in soil cultivation in the traditional one. In economic aspect, these are the
Okay. And
numbers.
what are the okay? And what are the key advantages of using soilless systems for spice cultivation?
For spice cultivation alone, there are many dishes like fusarium, pythium, and all. So generally in ginger, if you have seen, people will cultivate one cycle, then they will give around 3-4 years gap, and to avoid this disease. So it will tend to leave 3-4 years in soil without any crop. So they will leave the land empty, unused for prevent. To avoid this disease, reducing the production. Production. So usually you can cultivate disease free. So you can achieve export quality, because in export quality, uh, in export pa- in export there will be parameters such as it should be disease free, it should not have any pesticide residues, and it should not have low curcumin content. It should not have uh, there will be many criteria like this while you try to export. So it is easily achievable by cultivating spice in soilless system, as you are not introducing soil. The cocoa peat is an inert media. In inert media, the presence of bacteria which can cause this much distractions will not be there. So as it is inert, the whatever we are introducing into the media is the only bacteria. If you are introducing Trichoderma harzianum, which is a good bacteria, it is the only bacteria which will survive
Okay.
in that media. So that is the advantage.
Okay. And can you explain the role of hydroponics in spice production without soil?
So you can't mention cultivation in hydroponics. So it is not ethical to mention spice cultivated in hydroponics, as we can't cultivate spice in hydroponics. We can cultivate spice only in soilless medias like cocoa or there are many medias like this. You can consider hydroponic system as a soilless system, but you can't consider this soilless system as an hydroponic. So you can't market your producers in hydroponically grown turmeric. It is not ethical, but you can market it as an soilless produce without the residue, without disease free. You can mention like that.
Okay. And what types of soilless systems are most suitable for growing spices?
So generally, uh, for beginners, it is most advised to go with only coconut media because it will not face many issues. They will not face many issues if they are going only with coconut. If you are getting little experience with it, you can go with different composition of media. So 25% coconut, 25% perlite, 25% vermiculite, something like that. So usually, if you're experienced and you're having a bit of experience, you can um, do trials with different media. It is okay to go with. But usually, for beginners, it is always advised to go with only coconut, only low EC coconut. While buying the coconut itself, there will be two categories. One is low EC coconut and one is high EC coconut. So you should buy the low EC one because the soil deposit in that low EC coconut will be low. So if you're if you want to try new medias, you can go with 75% coconut and 25% perlite, but the cost of cultivation will be higher. The cheapest way is only going with coconut.
Okay. And next question is, what challenges are associated with spice cultivation in soilless environments?
The main challenge will be irrigation. So if you're not measuring that DO, which I mentioned earlier, dissolved oxygen and soil moisture, if you're not regulating these two parameters, then you will start facing the issue of disease, rhizome rot. Mm, It will come on and on. Like whatever the traditional farmer is facing in soil system, you will also start to face these same issues. So it is always advised to check dissolved oxygen content and soil moisture. Whenever these two parameters are ideal, the challenges are way low. Other than these, the challenge will be around the pest, like small pests such as spider mites, lace wing bugs, tends to come in control environment agriculture. So you have to do scouting every day and keep an eye on pest. So if you are seeing some spider mites in few plants, treating those plants first will solve this issue. Other than pest and disease, the issue might be managing the farm. So you should be in the farm every day. So it is not like you can come one day after on. I mean alternate days because in soil you have a buffer. So buffer time, like if you're not irrigating your crop for 1 or 2 days, it can withstand. But in soilless system, the crops can't withstand the buffer. They don't have a buffer time. So if you're uh, not irrigating at that proper time, it will start to wilt. So after some time, if you're not completely ignoring the crops, it will tend to die. So it is always advised to visit your farms on a regular basis, on daily basis. So other than this, there are no challenges in cultivating in soil system.
Okay. And are there environmental benefits to adopting soils as systems for spice farming?
Yeah, as I mentioned, in normal farms you can't control temperature and humidity. So if the temperature goes beyond the leaf term goes beyond 30 degrees, the photosynthetic rate of the crops will reduce rapidly. So resulting in lesser yield. Combinedly, the yield will be low if the photosynthetic rate is low for a long period of time. So in these systems, we can moderate the temperature and humidity as per our needs. So that leaf term will not go beyond the limit, causing a steady photosynthetic rate, resulting in higher yields. So that's the advantage.
Okay. And how can technology enhance the efficiency of soilless spice cultivation?
For a technology by aspect, yeah, as I mentioned, that you have to go to the farm regularly for maintaining the crops. We can implement technology such as um, automatic ECPH dispenser. So you can regulate your farm from using IoT technologies. So there will be fertigation systems like I guess Nido. It is a company which is providing an equipment which can facilitate this. So from your wherever you're staying and your farm is uh, it is very away from you, you can from your app itself you can monitor the crops. You can take the ECPH measurements. You can even irrigate your crops from wherever you're living, and everything can be done from where you sit. And you don't have to go to the farm regularly. You can also include drone scouting. Uh, there are many AI tools which are coming in these days, which can like if you're manually if you're checking, there are apps like Plantix. If you're taking the photo of the pests in that Plantix app, you will know which pest is this. So you can collect that API from them, and you can integrate it with your drone, and from wherever you're living, you can do scouting from drone itself. So like this, you can reduce the manpower used in the farms. So there is no need for one person in the farm looking after the crops. You can do whenever, wherever you are. These kind of technology can be implemented in soil systems.
Okay. And can you share some success stories or case studies of spice cultivation using soilless methods?
Yeah, our company itself is doing soilless crop cultivation. I mean, spice cultivation. So we started with an trial unit of 1 acre in Chennai. So the first trial was conducted last year. So it was successful. So we moved with the so first for the first trial we used 5 different varieties. So in the next trial we shortlisted which variety performed well. So we took that variety and did the second trial, which also gave a good, which is currently going on, but the results are good as for now. And then we have bought an 50-acre plot near Tenkasi in Tamil Nadu. So construction is going on for around 15 acres. We are going to cultivate turmeric and ginger. Ashwagandha is next in pipeline. So in Chennai we are doing this, and for in North India, and company herbal company is doing this. So they are cultivating turmeric in soil system as we are, and they are also exporting these crops. So their name Kona something. I forgot the name, but in UP I think they are cultivating this and they are exporting it. So there are many stories coming up. So for example, which as far I know, these two are going good, and many companies are also trying the same.
Okay. And just two more questions. How
Yeah.
does nutrient management differ in soilless spice cultivation?
From what?
How nutrient management differ in soilless spice cultivation compared to the traditional and compared to traditional, how it is different?
So in
Does it differ?
traditional, yeah, in traditional you will use urea, DAP, uh, and the NPK fertilizer. Uh, these fertilizers are not completely available to the crop, so it will take some time to change forms to get available, and most of them will leach down to the groundwater, affecting the groundwater ecosystem, and it will leach to the nearby water bodies, causing algae growth in the water bodies. These are the environmental impact of those fertilizers, but the fertilizers we are using is water soluble, so these are 100% available to the crops. We don't need to change forms to become available to the crops. It is readily available, so the crops can take as it is. And also we are giving exactly what the crop needs at exact times. There will be not the leaching effect will not be there in soil systems. So it is not a recirculating system, but it will not leach the extra nutrient into the soil. So the environmental impact is also good. So it will not cause any uh, damage to the nearby water bodies. It will not degrade the water quality of the groundwater. It will not degrade the soil quality beneath it. So usually the environmental impact aside, the crop we are cultivating has a good impact because, as mentioned, nutrient uptake is high, resulting in higher yield and quality.
Okay. Okay. So before we end, one last question. Can you share some details about your career background and what made you to take an interest in this particular field?
Yeah, as per my career, after completing my high school, I started to go to an institute in Bangalore, which specializes in soilless spice cultivation. So it is near, I think, Elahanka in Bangalore. So they're providing an complete in-depth course for 3 months where you will learn A to Z about spice cultivation as well as normal hydroponics also. So in these 3 months, I learned the upcoming market for this and the demand for this. So I thought this career could be in boom in next few years. So which made me proceed with the same. And also I am doing BB in Manipal University as an online course. And as far as now, I am working in Way to Grow in Chennai. After completing my Bangalore course, I joined Way to Grow, where we started first trial of turmeric cultivation. Then we had many crop cultivations like cucumber, capsicum, and all. So the the main impact would be the climate change. So when I saw the news that 17% of Bangladesh will sink underwater in 2035 or so, so these numbers are very high. So there are many nations that are in the brim of collapse due to climate change. The only way they can satisfy the food production needs of domestic needs is via technologies like this. So you can't cultivate crops in a soil which is uh, the fertility of the soil is way too low due to the salt accumulation, and the groundwater resource will start to deplete. And these factors will also impact us in coming years. But it is good to have a knowledge in these systems before these scenarios start to have impact on us. So I chose this career due to this.
Okay. Okay, Mr. Gyaneshwar, it was good
Thank
to
you.
talk to you, and thank you for the detailed presentation and answering all the questions in depth. And
Thank you.
so now we have come up to the end of meeting. And we also
Yeah.
like to thank all the participants for joining this meeting in Noble Closed. Have a good and safe evening.
Yeah. Thank you. Same to you.
Thank you.